Hi, everybody. This is Nalini Elkins with Industry Network Technology Council. I hope you can all hear me okay. Maybe somebody can send me a quick note and let me know how the sound is. As always, this webinar is being recorded. So I am Nalini Elkins. I'm president of the Industry Network Technology Council. We are a nonprofit who is a consortium for industry, and our aim is to act as a bridge between the standards bodies such as the IETF, ICANN, and others, so that that industry and academia knows about what's going on. And as you will see from this webinar, there is a great deal going on that will affect enterprise networks. Yes, TLS 1.3 is a major change that we all really need to think about. So this is the agenda. We'll discuss some of the TLS handshake differences between 1.2 and 1.3. 1.2 is generally what's out there today at enterprises. 1.3 is permeating the internet more and more. Interestingly enough, I guess it's been 4 or 5 years already that it has been an RFC. Time goes quickly. We'll talk about some of the implications of TLS 1.3 for enterprise networks, and then we'll talk about some of the new drafts that are coming up that also will have a great deal of implications on how we run our networks. And then, of course, as we have been doing for the past few times, consider post-quantum and how that will affect us. So what is TLS 1.3? TLS 1.3 is the latest standard of TLS, Transport Layer Security, which is the most widely used protocol on the internet for security. And TLS 1.3 was standardized in August of 2018. And as some of you may know, we were quite involved in various discussions around this at the IETF. TLS 1.3 in many ways is the start of a much newer way of doing cryptography and doing the how TLS works, and it is the foreshadowing of a great deal of work that's happening at the IETF, and much of that has to do with encrypting more and more of not just the payload, but the metadata and anything that might leak out over the internet. TLS 1.3 is also embedded in many of the new protocols, such as QUIC, DNS over HTTPS, and so on. So it is very, very important to know TLS 1.3. It's the building block for many things, many of the other protocols on the internet. So what are some of the most important features? Much more of the handshake is encrypted, and we'll start looking at the packet with some packet traces. I'll show you some handshakes so you can see exactly how it works and what is encrypted. There's also improved performance. The handshake size has been decreased, and you can now do send data early. They call it early data. You also hear a lot of talk about 0 RTT, 1 RTT, and so on. What they really mean is they're talking about how many round trips does it take until you get to the point of doing sending actual data. Since handshakes are overhead, and what we really want to do is send data. Having said that, when you look at the post-quantum stuff, this is changing things greatly because of how post-quantum signatures in particular are going to work in the certificates. The performance issues that is the subject of a great many drafts and a great deal of thinking at the IETF today. How are we going to handle post-quantum in TLS? And these changes will be made to TLS 1.3 only, most likely. One of the biggest things that happened at the last IETF, which just finished a week or two ago, is that there was a draft that was proposed which said that TLS 1.2 will now be frozen. As we will talk about that in a bit after we get through the handshake. There are a huge number of implications to freezing TLS 1.2. The biggest one is that that any post-quantum cryptography will not be in TLS 1.2. As we go through this presentation, we will look at all the implications that has on how we manage our networks. There are a number of deprecations that were done in TLS 1.3. Many of them have to do with key exchanges. Again, key exchanges that enterprises use and have network management implications. A great many cipher suites were also deprecated, as I say, and then some of the hashing techniques, SHA-1 and so forth. But that is, as I say, that has been coming for a while. So that is no surprise. Let's keep going. So what I'm going to do now, I'm going to run you through a couple of traces, and then let's see what we see in both TLS 1.2 and 1.3. So we're going to start out, first of all, by setting up our environment variables so that we can decrypt the trace. I'm going to be taking a packet trace. So the reason we want to be able to decrypt is as I said, in TLS 1.3, quite a bit of the handshake is encrypted. And if we don't decrypt it, we won't even see what the packets are. So this is how you start up. You set up this environment variable. It is called SSS keylog file, and you just give it the name of a file on your PC. I happen to be on my Windows machine, so that is what I have done. You can, of course, set this in Linux, Mac, or whatever. Curl, I believe, also accepts it. So, and when that file is created, you'll see what it's doing. It's writing out all the secrets that are needed for decrypting the packets. At some point, we can go through what is in this this file. That particular discussion of exactly what is in there can take probably a couple of hours in itself. So we will avoid that for now. But this is the method that is recommended by the IETF for how to store secrets securely and can validly be done only at either end, either the client or the server, as those are the two end points. And this one, I'm going to be using the Chrome browser, and Chrome and Firefox also support this. In fact, one of the developers for Mozilla, actually, I remember when this thing was being first put into Firefox. we all work together on exactly what should be in there. The same methodology is used for Firefox and Chrome. Internet Explorer does not use SSL keylog file. So, and one of the things about this is once you put it in, it's going to put in the secrets for every session that goes through on your Chrome or Firefox. It can get quite big. So we've got this file. So then what do we do? So then in Wireshark, what we're going to do is the Edit Preferences selection. We'll scroll down to the TLS protocol, and we will point to that file. And so what that will do once we've done that is now we can go ahead and see all the packets which will be now decrypted for us. So let me show you. So then let's start taking some traces. So what we're doing now is we just, I just set up my Chrome and started doing some packet traces. You just let it go. And whatever you're doing, going to Google, Facebook, or whatever you do, most likely it's going to be using TLS 1.2 or 1.3 generally, but it's going to be using TLS. You may be using a back version. I hope you're not. But in any case, what we need to find out is here we've got this handshake. Well, let's see what is in there. Is it 1.2 or is it 1.3? Let's look at this some more. Okay, so one of the first things you'll find, I am in the client hello, which is the first packet that's sent. And if you are not familiar with the handshake, you may wish to go back and see the presentation I did a bit ago on the TLS 1.2 handshake, where I went through all the packets in the handshake, so you can refresh yourself on what all the packets are and what they do. As a summary, the first packet that is sent after the TCP handshake is the client hello. It is sent by the client to tell the server, I want to do a TLS, and these are the ciphers that I support. And as you can see from all the various extensions, there are a great many configuration options, if you will, as to how I want to communicate. As I say, we only have 1 hour for this. We could spend several hours at a minimum going through these extensions alone. But as I say, this will at least demystify some of this for you, and then you can possibly read yourself. But the first thing we see that the version is TLS 1.2. And so then you think, well, why am I saying, is it really? The reason is because it always says that, but that's not exactly what it is always. So let's just see, what is it? Let's see what we agreed on. Okay, so then we start looking inside the client hello, and we see, what does it support? And the client says, well, I support TLS 1.3 version 304 and TLS 1.2. Let's leave the grease aside for a moment. That was a transition, if you will, a transition mechanism that was used. Let's just concentrate on 1.3 and 1.2. So what did we actually negotiate? So then when we go to the server hello, what happens is the client asks the server, I want to do TLS, and the server responds back with what he has chosen from the options provided to him by the client. And you'll notice here that there are far fewer extensions. And in fact, supported versions is not there. And again, in fact, if you look at these extensions, they are TLS 1.2 extensions, and the cipher suite itself is a TLS 1.2 cipher suite. So therefore, this handshake is TLS 1.2. You know, it's a somewhat roundabout way of getting to this, and if we could just trust this to be the right number, all our headaches would be gone. But well, there we are. So now, one of the things you'll notice is that now that I have done SSL keylog file, even though this handshake is shown, even though this is now, of course, encrypted data, you can see exactly what is in the packet. And that is, of course, very helpful if you're doing debugging. So now let's start looking at another one. And now this is a TLS 1.3 handshake. Let's look at and we can see even things like encrypted extension, certificate, verify, and finished because of SSL keylog file. Otherwise, we couldn't even see that. And of course, when we start seeing things like encrypted extensions, we're like, aha, this is probably TLS 1.3. But we'll of course want to verify it by looking at inside the packet. So if I did not have SSL keylog file, this is all you would see. What you would see is the client hello, you would see the server hello, and then as things go on, you see the change cipher spec to go on. You know what? I see a hand raised by one of my collaborators. Let me see what he has to say. Okay, Mike, I have unmuted you. Is there something you want to say?
Thank you, Nalini. I was going to ask a question. I was just starting to type it into the questions thing, if you'd prefer me to do that.
No, or you can just go ahead and ask it.
Okay, yeah. So on one of your previous slides, on one of your previous slides, you were showing in the server hello, the cipher suite, and in the name of the cipher suite are the characters RSA. What does that imply?
You know, okay, so of course Mike is going to ask this question. Mike has been my partner in crime throughout all this TLS saga, and he has really hit on something which we will dwell on coming out. And Mike has hit it right on the nose. What RSA again implies, and again, one of the reasons I know this to be a TLS cipher suite is that we are using an RSA key exchange. That is what that implies. And TLS 1.3 has deprecated that. And we'll talk a great deal about that as we go on. But Michael has absolutely picked up on the right thing is once you see RSA, that is no longer supported in TLS 1.3. And so you're like, this cannot be TLS 1.3. It's a previous version. Have I answered your question?
You've answered it perfectly. And I want to say one more thing, and you listen real closely and make sure I say this right. The fact that it says RSA there implies that it's using RSA keys, which means that we could use some of our old mechanisms if we have those keys and we've shared them properly and done all that, which a lot of us have done. But if it doesn't say RSA there, you could have a 1.2 session without those keys and then still need to do the SSL keylog that Nalini has outlined. And if you're not able to do that, like she's showing us today, a whole lot of our platforms will stop working. So I think that's kind of important, because for me, I see in my network TLS 1.2 sessions that have RSA, and I can still do things with key exchange there. But I also see things that don't have RSA in there, and I'm helpless. So I just wanted to try to make that point, and I'm going to go on mute, and you tell me if I said things properly.
That is wonderful, Mike. And in fact, when we have a whole section on that coming up, and please please unmute yourself again if you want to say stuff, because we want to really stress that point. And I'm glad you're making that now, because pretty soon that's exactly the discussion I want to have with everyone is, I want people to understand what the implications are of TLS 1.3 and the fact that TLS 1.2 will now be frozen in function, most likely. So I'm gonna call on you, my top student. No, I'm teasing you, my partner in crime, and then we'll talk a great deal about that. So getting back to the TLS 1.3 handshake, what do you not notice here? Well, you see the client hello, you see the server hello. Hey, where's my certificate? That's one of the big things we all look at, isn't it? Is because a lot of times what happens is that the certificate has expired, you get an error, something like that, and then you can't see it. Mike, go ahead. Did you have something you wanted to say in this area?
No, not at all. I'm sorry. I was trying to put my hand down, and I think I put it back up. Sorry about that.
All right. So just raise it again if you want to see something. But that certificate is actually this application data packet, which is in the middle of this whole handshake. And without SSL keylog file or some such thing, you're not going to be able to see that. That's a big drawback. Okay. Now, let's look again inside the client hello and look at the supported version. Again, we see 1.3 and 1.2 supported. But this time, when we go over to the server hello, what we see is, we see that TLS 1.3 was negotiated, but darn it all, what do we see up here? We see TLS 1.2 still up here. So don't let that fool you. This is not a TLS 1.2 handshake. This is a TLS 1.3 handshake. And to stress the point that Mike made just a bit ago, you notice here, do you see RSA in here anywhere in this cipher suite that was agreed on? You do not. And we'll talk about what the implications of all that are coming up in a moment. Okay. The other thing you'll see is again, when I eyeball the handshake after I decrypt it a little bit and I see encrypted extension, that's my first clue that this is a TLS 1.3 handshake. And this one, you'll see application layer protocol negotiation. And so you'll see there's, as I say, there's a bunch of things that you can send encrypted. And frankly, more and more and more is being sent encrypted. And so you'll see more encrypted extensions coming up. This is where we're going. So, in fact, there's a huge movement to encrypt the client hello itself. This actually has been adopted by the TLS group. It's not an individual draft. When it becomes a working group item, what that means is that over time, and time may mean anything from 6 months to 10 years, often in the 1 to 2 year time frame, sometimes more, it will become an RFC. And even though there are no protocol police, and the IETF is not, does not, you can do anything you want, right? But you won't be able to interoperate if you don't follow a lot of these RFCs. And of course, a lot of the RFCs are in the RFPs requirements set out by the federal government and others. So it is likely, if something becomes an RFC, it is then likely that it will be implemented. And in fact, encrypted SNI is being implemented. I just was reading a blog, Cloudflare blog on how Cloudflare and Mozilla have both implemented encrypted SNI, encrypted client hello and encrypted SNI, which is embedded in there. Again, this whole discussion can be at least a 2-hour discussion, so I'll just leave it at that, so that you know that more and more of what we see is becoming encrypted, and the large vendors are implementing it. So let me back up a little bit, and this will bring to light some of the disputes that we have been having, and I'll ask Mike to jump in again to make it more interactive. So Mike was at my side throughout all these horrible years when we were fighting at the IETF. There are 2 points, at a minimum, 2 points of view in this arena. But let me just talk about 2 points of view. The one is for the privacy advocates, and the other is the large brick and mortar enterprises. This is not to say that brick and mortar enterprises don't want privacy. Of course we do. We don't want data exfiltrated all over. And in fact, if you're a regulated industry such as health insurance, there are regulations, HIPAA, so that there will be fines if personally identifiable health data is exfiltrated. So of course we want privacy, but we need to be able to manage our networks, do fraud monitoring, malware, many things. I am just sort of joking, but some people cynically call TLS 1.3 the hacker's best friend. So one of the things that I'll just say these two groups agree on, taking a very large view of encryption, is that what the point of encryption is to hide things from people who wish you harm. Sure, of course, yeah, but the problem is, who exactly is the bad guy, and what are we trying to hide, and then how are we going to do it? In some ways, the kind of the collateral damage of what has happened at the IETF is that we have to figure out new ways to do things. Otherwise, everything that is hidden from hackers is also hidden from us and our ability to manage networks. You might also care to look at a presentation that Paul Vixie invented, basically DNS, and bind. He did the first version of bind. Paul spoke for us at the joint conference a year or two ago on what keeps him up at night, and he's spoken at NANOG and various other areas about what keeps him up at night, and exactly the stuff that I'm talking about is what keeps him up at night, is how do we run our networks when the stuff that's supposed to be hidden from the bad guys is also hidden from us. So what am I exactly talking about? I'm talking about the topic that Mike started a bit ago, which is a one-line change in a very early version of TLS. And so I will say this happened before Mike and I got involved in the TLS 1.3 discussion. Otherwise, we would have brought it up at that time. We by the time we got involved, it was already a year or two past when they had made the change and had the discussion on it. So they removed the support for static RSA and static Diffie-Hellman key exchange. Why is that a problem? What happens is that in reality, what enterprises do today, they use long-term private keys, RSA private keys, and they're saved and put into a lot of decryption devices. Let's say your malware, your deep packet inspection firewalls, whatever you've got, web proxies. And in a moment, I'll see if when we have the discussion, I'll see if Mike wants to come on and talk about how they actually use it at their large enterprises. He works for a very a large insurance company, and so he can talk hands-on about how they use it today. So, what kind of enterprises? I mean, because you think, well, what's an enterprise? It's anybody who's got a private network that they operate, something that's not the internet. And so, who are these people? Well, the business and governments of the world, basically. Also, it's all of these people. In fact, I would say probably most of the people on this particular webinar belong to some of these groups. It's anybody who's running a large private network. Again, how they solve problems today on their network, in the end, you probably have to do some packet decryption. And if you're going to do deep packet inspection, then what you have to do is you need to be able to decrypt the packet. That comes back to what? Needing that RSA private key. That's how you do it. So that's let me stop right this moment and see, Mike, do you want to add anything else to this particular discussion?
I think you covered it pretty well. I think I just want to reemphasize a couple points that you made. One is that where there's the good guys and the bad guys, we enterprises, and you did say this, but we're not against privacy. Not only are we in favor of it, but we're mandated by many organizations to do it. So we need it too. But what we also need is exceptional situations where we might need to decode that packet for diagnostic purposes, security reasons, etc. And just a couple quick examples would be, your sessions with your customers, whether they're internal or external, are going along just fine, but all of a sudden one of them, or many of them, or worse yet, all of them are having a problem, and it's not something you can see in the TCP header. So you need to decode that packet and see what's going on there. Is it a login problem? Is it an HTTP problem? It could be a number of things, but you need to decode that packet to find out what the problem is, much less be able to fix it. So that becomes of critical importance. And so we need to be able to do that, and we can do that today with the RSA keys. If those go away and we can't do that at all, what do? Let these problems go on instead of for minutes or hours, for weeks and months, or do we go out of business? And maybe I'm exaggerating, but it does concern me. So that's the perspective that I wanted to give. And then you also mentioned that maybe I should say, like, how do we do it? So in our visibility engines, which might be Gigamon or NetScout or even Wireshark, however we're looking at these packets, we load the RSA keys in there today, we would need to do something on those platforms in the future. And if not, some of those platforms are going to cease to function or function effectively. And I will extend that beyond just the diagnostic platforms to security platforms such as IDSs and IPSs. So these are pretty critical platforms for us. So there, I'll take a deep breath and stop now. That's I think all that I wanted to say to add to what you had said. Thank you.
Thanks, Mike. Yeah, I think it's like I'm glad to have a more interactive solution, a webinar. I think it makes it better for the students. So thank you. So now let me say, I completely agree with the cryptographic deprecation of RSA, as well as static keys. As a cryptographer or would-be cryptographer, from that point of view, it's completely the right thing to do. What we need, though, is a transition mechanism, and for enterprises to be aware of how it impacts them and transition their networks. We've talked. If you want to, you can go back to some of the previous presentations I've done, where I talk about how quantum computers work and how RSA in particular is at threat because of Shor's algorithm. And so I completely, as well as a number of non-quantum attacks, RSA is not a good key exchange mechanism. I will, let me not, I don't want anybody to say Nalini said we want RSA back. We do not want RSA back. What we need is for enterprises to be aware of this issue and transition themselves. As I say, we'll talk a bit about quantum computing, but as I say, if you want to go back and hear, quite a bit more of what I said, you go back to some of the earlier sessions and talk about this. So anyway, this there is a draft, and again, this has been adopted. It's an IETF TLS draft. It's not an individual draft. It will deprecate RSA within TLS 1.2. So, as I say, if you think you're going to be able to use TLS 1.2 with RSA for a long time, you won't. The other thing, this just happened. At the last IETF. And you'll see this when you see draft this is the author, Richard Rich Saltz, I think that's his last name. Yes, of course it says. He's one of the developers of OpenSSL. A wonderful person, by the way. I mean, just a dear person. But he suggested that we freeze TLS 1.2. And again, there was a great deal of discussion, meaning argument about this, because so many enterprises are at TLS 1.2. And TLS 1.3 is really not being thought about at enterprises. So let me stress, it would be time to think about how you're going to live in this new world once TLS 1.2 is frozen. The biggest implication of TLS 1.2 being frozen is, and then RSA being taken out, is on your network management. And the next thing is, if you freeze TLS 1.2, none of the post-quantum cipher suites will be in there. I'm going to talk about that just momentarily, but that is huge. Most of the work I do these days is in post-quantum, and many of the people that I know, that is where they are right now too, is working on integrating post-quantum into their thinking, their offerings, and talking about it. This is adopted, the hybrid key exchange in TLS 1.3. So this is the way that we will start using post-quantum cryptography today. And this has been adopted by the working group. Let me tell you, there is a great deal of discussion and thought and work going on behind the scenes about other proposals also. But this is what is there today, has been adopted. I suspect that this is probably the area that most work will be done for the next 2 or 3 years at the IETF at least. So the other group you may wish to follow is the post-quantum use in protocols, PQIP working group. I've talked about this some more in the past webinars, but do please take a look at some of these and start getting yourself familiar with at least the terminology for what we're going to be talking about for the next 10 years, I would say, at a minimum. So as I say, this terminology draft is really good. There's also a post-quantum for engineers that's being worked on. That also is quite good. It tries to demystify some of these things. I'm not saying it really does demystify it, because it still makes reference to things that it assumes everyone knows, such as Shor's algorithm, which not everyone knows. But as I say, look, please do take a look at some of the earlier presentations. I did 3 presentations on terminology, just so that people can understand when they go to start reading these drafts, what is supposed to be assumed knowledge on these things. And down the road, when I get some free time, I will see if I can explain the new post-quantum mathematical algorithms in a reasonable way, but that may take some time. I'm in the middle of a few things right now. So how it will work right now is that in terms of the changes for where we're going to get to, is we need new cipher suite, and NIST has standardized some. There's still work in this area, so do follow NIST. We need changes in TLS. That's happening right now, the key exchange. We need certificate and signing changes. That is happening right now also. This is a huge area of change, discussion, and so on. To cut a long story short on what the problem here is that certificates, instead of the signing key to be 16 bytes, less than 1,000 bytes, let me just put it that way, relatively small, is now many thousands of bytes. And this becomes especially problematic when you have chained certificates. You have your root, intermediate, and so on. So this is a big, big area of thought, and many of the drafts you'll see and the suggestions, as well as the discussions that people are having behind the scenes, is on how to handle this whole certificate and signing changes. Then things are being implemented in crypto libraries. There's an experimental version of OpenSSL, which some of us are playing with. But then you have to put those. OpenSSL is fine, but if you're using Java, you need it in Bouncy Castle and so on. There's other issues, but anyway, so this is where right now things are. Is we need the implementations in the crypto libraries. As far as I know, the compilers have not made the changes. That is where we are right now. And then, of course, the web servers. There are some web servers who are using the experimental OpenSSL Crypto Lib. But anyway, all this is likely to be where we are for the next 10 years. So this is, I guess, a kind of a long-winded way of saying that this whole area of TLS and post-quantum is likely to be undergoing changes for the next 10 years. And the impetus is to prepare us for the quantum threat. And so you might consider keeping up on this whole area. So, any thoughts, questions, discussions from anybody? Let me see if I've got any questions in the questions window. So, is everybody sufficiently overwhelmed? I'm sorry. I'm going to see if Mike has anything to add, because, as I say, this is the world we live in, and it can be overwhelming. Yeah, go ahead, Mike.
I really don't. I was thinking about a possible future topic, and you kind of brushed on it today too. So I'm going real slow here, so you can tell me to shut up and you'll address this in the future, or maybe we don't want to address it at all. And it's a situation where maybe the client and the server are in different domains or controlled by different companies, which is a situation all of us enterprises are in. In other words, I have the client or I have the server, and maybe one of my partner organizations, another company, has the other partner, and they have different lists of cipher suites and what challenges that might present. Is that a good topic for future, or should I mention it briefly now, or just go quietly back to sleep?
No, I think you can talk about it, but that particular problem, really, that exists no matter if you're using, you could have that problem with TLS 1.0, I mean, your server.
No, absolutely true.
Right, go ahead. Yeah.
No, absolutely true. So, all right, I'm going to talk about it I'm going to try to wrap this in 30 seconds. So and don't go back to that trace, but the trace that you had in there, the client said, oh, I want to use RSA. And then when the server got back, he said, no, I don't want to use RSA. So if you're depending on RSA for any of your security or diagnostic platforms, it's not going to be in effect for that session. So do you transition one side or the other, or what do you do there? Or can you have some proxy device or something in the middle? It's just, to me, it's a scary, challenging situation that we are going to have to address in the very near future, and maybe happening today as your trace portrays.
Yeah, as I say, what I will say is the work that I know that's going on in this whole arena from a number of different vendors. And so I will put a caveat out there is, I have a conflict of interest in this area. My lawyer says I have to say that. I have a conflict of interest in this area as we have products in this space. There are people who are working in this arena, and many of them are doing, quote unquote, some type of box. The problem is, what box? Whose box? Does it interoperate with other people's boxes? It's all getting much more complicated in this area. But in some ways, I have hope that this is a problem that we've had since TLS 1, or even SSL 3 or 2 came out. This is a long-standing problem in the industry, is how to transition from one protocol suite to another. What happens? I mean, how many cipher suites do you support? What the server overrides the client? What if that's not what you want? My hopes are that we need to rationalize some of this chaos and come to an answer. Don't get me wrong, I have no hopes that we'll actually do this, but my hopes are that this will serve as an impetus for us to actually solve some of these long-standing problems. Did I even begin to answer your question? Did I go off?
Yeah, no, way more than answering. And the only thing I would add to that is, and kind of my original intent was, let's see if other people, if you can get feedback on this, would be concerned about that situation like I am, or maybe I'm all alone in that regard. But I'll add to hopefully the consternation by saying it may not be just your organization and then another company. It may be your database server and your web server, because the web server has to get upgraded and the database server can't get upgraded yet. And now you have this disparity in cipher suites that may cause you some issues along these lines. So it's just, you mentioned what keeps Paul Vixie up at night. Those are some of the things that keep me up at night.
Yeah, no, if anybody else wants to join the conversation, please do. I mean, Mike and I get a bit excited about this whole arena. But it's an important thing, and I totally hear what you're saying. I've certainly talked to other large companies who have exactly that And in fact, it was exactly a database server and an application that was using an old database that was using an old mechanism that could not be upgraded. And in fact, they were getting, their security team, penetration testing team, and so on, were security audits. They were failing the security audit for that very reason. So, yeah, no. So if anybody would like to, please do contact me. I'm happy to talk. If you think of questions afterwards, please do tell me. I know we sort of go, can be kind of like a fire hose sometime in this whole area, but that's because this is kind of where we live right now. For good or ill, this is where we. So, okay. Well, so thank you all so much. And the next webinar will be on some IPv6 neighbor discovery work that we are doing in collaboration with the university in India, and I hope to see you there. And Mike, thank you so much for all your excellent questions and interaction.
Well, you're more than welcome, and let the thanks go in your direction. Though this is excellent stuff. It's stuff we all need. And what you've put together here, I mean, I remember when I tried to look into SSL keylog, I didn't even know that it existed, much less how to use it, much less how to make it decode data. And you've showed us all that in a very usable and pretty friendly fashion. Thank you so much for doing that.
Okay, thanks, Mike. Okay, so thank you all for attending. Bye.